Welcome to this revision video on the information processing model as part of cognitive psychology for stage 1 psychology. Let's get started. So before we talk about memory, we need to first look at how information is actually processed in the brain. So the information processing model is the stages of the information processing approach that deals with incoming information from all the body's senses. So there's 5 stages to this process, as you can see here. So stage 1 is the information enters the relevant processing centers of the brain. Stage 2 is that they are then interpreted using our previous knowledge and contextual cues. Once this has occurred, we make a decision about the information, so whether it's important or not. We then select a response as part of stage 4, and then stage 5, we make the response. So all of this happens very, very quickly, but it is one of the most important aspects of how our memory works in terms of how information is processed in the first place. So this is the information processing model or approach summarized here. So again, we've got our incoming information. We have the sensory processing of that information, obviously using the senses, so sight, touch, taste, etc. We then interpret that information, whether it's relevant or not. We then need to make a decision regarding that information, select an appropriate response, and then carry out the response, as you can see. So stages 2, 3, and 4 involve both short-term and long-term memory. So an example of this might be hearing a door slam. This is your incoming information. So the sound is processed in the auditory cortex of the brain, which is stage 1, and we recognize it as being a door as opposed to other objects in our surroundings. So this interpretation of the situation of the door slamming will rely on our knowledge of how a door might have slammed based on previous experience of hearing this. So if there is a person close by, we might interpret them as having slammed the door, and we'll consider what their emotional state may be at this time. So this will then inform our decision, so stage 3, about whether this was purposeful or not, or whether it was an accident, for example. If we think it was, our response might then be to check in with the person. So if we think it was purposeful, we might check in with the person to make sure that they're okay, because often, obviously, when we slam doors, it's usually in response to something quite emotional, for example, anger or fear. So in psychology, we often think of the brain as a computer in the way that information is processed. So we can use this to compare the processes between human memory versus computers. So this analogy is useful. It is obviously important to remember that the brain is a complex biological system that cannot be fully understood by such a comparison, but nonetheless, it is still a useful analogy to use. So let's look at the processes of our memory and how we process information and liken that to computers. So encoding is the process of incoming sensory information into a form that can be stored as a memory. Storing is the process of forming new neural networks between incoming information and previously learned information to form a memory, and it is stored there temporarily if in the short-term store. Retrieval is the reactivation of a neural network, bringing remembered information into the working memory for us to use. So it's summarized in this table. When looking at computers and encoding, encoding in a computer requires turning information into a representation made of binary codes. In humans, it requires processing information from the senses. For storage in computers, storage in a computer comprises of the use of folders and file systems, whereas in humans, storing in a human involves forming new neural networks between the incoming information and previously learnt information. And then retrieval. So in a computer, retrieving in a computer requires the loading of the folders and files from the memory storage unit to the central processing unit, whereas in a human, retrieving in a human requires the reactivation of these neural networks and pathways, bringing the information into the working memory for use. So each of these processes, so encoding, storage, and retrieval, are important in memory formation. So if there's any problems at any stage, memories will not be formed or may not be remembered correctly. So if information is encoded incorrectly, that information may be incomplete. So if you're not paying attention when a car drives past, for example, all right, you may remember the color as it was your favorite, but you don't remember the model of the car. So you won't be able to store both pieces of information, and only the color is likely to be recalled. So storing is also important as it creates a new neural network relating the information or relating it to the information already stored in the brain. So retrieval is the final step in being able to recall information and will only occur if the first two stages have been completed properly. So memorizing and recalling information cannot occur without these three processes being successfully completed. So I hope you found this video useful. As always, if you've got any questions, let me know. Otherwise, happy revising.